MS Ramaya University of Applied Sciences.
Hi students, let us discuss DPSK scheme. The aim of the experiment is to study differential phase shift keying. In differential phase shift keying, DPSK, the phase of the modulated signal is shifted relative to the previous signal element. No reference signal is considered here. The signal phase follows the high or low state of the previous element. This DPSK technique doesn't need a reference oscillator. The following figure represents the model waveform of DPSK. Apparatus: Syntec 2156 and 2157 kit with power cords, digital oscilloscope, probes, connecting cords. The connection diagram is as shown. Procedure: connect the power supplies of Syntec 2156 and Syntec 2157, but do not turn on the power supplies until connections are made for this experiment. Make the connections as shown in the figure. Switch on the power. On Syntec 2156, connect oscilloscope channel 1 to clock in and channel 2 to data in and observe the waveforms. On Syntec 2156, connect oscilloscope channel 1 to NRZL and channel 2 to output of modulator circuit I on Syntec 2156 and observe the waveforms. Adjust the gain potentiometer of the modulator circuit 1 on Syntec 2156 to adjust the amplitude of PSK waveform at output of modular circuit 1 on Syntec 2156. Now on Syntec 2157, connect oscilloscope channel 1 to input of PSK demodulator and connect CH2, that is channel 2, 1 by 1 to output of double squaring circuit, output of PLL, output of divide by 4, divide by 2, observe the waveforms. On Syntec 2157, connect oscilloscope channel 1 to output of phase adjust and channel 2 to output of PSK demodulator and observe the waveforms. Now vary the phase adjust potentiometer and observe its effects on the demodulated signal waveform. Now connect oscilloscope channel 1 to PSK output of PSK demodulator on Syntec 2157 and connect channel 2 output of low pass filter on Syntec 2157 and observe the waveforms. Connect oscilloscope channel 1 to output of low pass filter on Syntec 2157, then connect channel 2 to output of comparator on Syntec 2157 and observe the waveforms. Now vary the reference voltage potentiometer of first comparator to generate desired data pattern. On Syntec 2156, connect oscilloscope channel 1 to NRZL and channel 2 to output of comparator on Syntec 2157 and observe the waveforms. Now try to match the LED sequence by once pressing the reset switch on Syntec 2156.
Hi students, current experiment is differential phase shift keying. The apparatus required for this experiment are 2156 board, 2157 board, Syntec 2156. We are using it for the phase shift keying, differential phase shift keying modulation scheme. Here data being coded into NRZ line coding scheme, and then the data stream is passed through the differential encoder, which we can see here. That is the differentially encoded data stream passed through the unipolar to the bipolar conversion then that unipolar to the bipolar converted data will be fed into the signal input. Here we are passing the 1.6 megahertz as the carrier input, 1.6 megahertz as the carrier input, and we are multiplying the data stream, bipolar data and the carrier signal, and we are going to get the differentially phase shift keyed modulated output signal. Now we are passing it through the PLL and low pass filter. Again we are going to pass it through the comparator. The output of this comparator is passed through the differential decoder. Differential decoder output will be fed into the data input, and we could able to observe through the LED the data outputted. Digital oscilloscope. This is digital oscilloscope. Main power switch of this digital oscilloscope is this one, and we have two channel this is a two channel oscilloscope, channel 1 and the channel 2. These are the magnitude adjusting knobs, and these are the horizontal position adjusting knobs, and this is the time scale adjusting knob. These are the connecting probes for digital oscilloscope, and these are the connecting wires for the Cytec 2151 board. Now let us start the connections for the experiment. In Cytec 2156, connect the clock output to the clock input and data out to the data in. Then NRZL to the differential encoder input, clock to the clock input, output of differential encoder to the unipolar to the bipolar converter. Then unipolar to bipolar output is connected to the signal input. Carrier signal of 1.6 megahertz is connected to the carrier input. Output of carrier modulators is the differential phase shift keying modulated signal that I am connecting output of the carrier modulator to the input of PLL, which is in the Cytec 2157 board. Then output of PLL is connected to the low pass filter input, and output of low pass filter is connected to the input of comparator. Output of the comparator is connected to the differential decoder. Differential decoder output is connected to the data input. And clock recovery for the PSK and DPSK is connected to the clock input of serial to parallel converter, and clock recovery of PSK DPSK is connected to the clock input of differential decoder. Now let us connect the ground of 2156 to 2157 board ground to create the common ground between the two boards. And now connect the probes for channel 1 and channel 2 connected to the clock and to the ground. The channel 2 probe is connected to the data, NRZL data, and to the ground. Now let us switch on the power supply to the board as well as the power supply to the digital oscilloscope. Press the auto set button and press the run and stop. Now we can observe clock signal to the board as well as the data stream which is generated of NRZL scheme. Now I am changing channel 2 probe to the output of differential encoder. Here I am connecting to the output of differential encoder. Again press the auto set option and run and stop. Now you could able to see the changes between the earlier data stream and differentially encoded data stream. Now I am connecting output of the differential encoded probe to the bipolar scheme. How unipolar to the bipolar operation took place, and connected to the nearby ground. Again press the auto set button and run and stop. You could able to see both the positive as well as the negative sides of the data stream. Earlier it was only 0 to 5 volts was the voltage. Now it is both positive as well as the negative voltages you can see. Then I can observe the carrier signal which is 1.6 megahertz signal sine wave. Press the auto set button and again press the run and stop such that you can see a perfect sine wave of 1.6 megahertz, which I am multiplying with the differentially encoded data stream which is converted from unipolar to the bipolar, such that I am getting a differentially DPSK, differentially phase shift keyed modulated signal. To observe that, I have to again press the auto set option and run and stop. Now you could able to see the abrupt change in the phase of the sine wave such that phase shift keying operation is carried out on the carrier. Now I can observe I am changing the probe from the output of the carrier modulator to the output of PLL which is there in the 2157 board and connected to the ground, and you can see output of PLL using the run and stop option. This is the output of PLL. Then I am connecting the channel 2 probe from the output of PLL to the output of low pass filter. So again press the auto set option here and run and stop. So you could able to see the output of low pass filter. This output of low pass filter is passed through the comparator, that we can see by changing the probe from the output of the low pass filter to the output of comparator. Again press the auto set option and run and stop. Again press the run and stop. Now you could able to see a bit stream which is received before the differential decoder. I have passed the data stream through the differential encoder. Now this is prior to the differential decoder. If I pass this stream through the differential decoder, I will get the data stream back which is transmitted. So to observe the data stream, I am changing the probe from the comparator output to the output of differential decoder. Now we are going to observe the data by pressing the auto set option and again pressing the run and stop. You could able to see the transmitted bits as well as the received bits are looking similar. The other way of observing the same thing is through the LEDs. So now let us switch. These are the transmitted bits through these switches. Now I am switching off all the bits. Only the bit which I am transmitting is the framing bit, that is the D7. Now you could able to see the LED which is glowing there is D7 only. The rest of the LEDs are off. Now I am switching on the D1, D2, D3 and D4. The other side of that 2157 board is showing the LEDs D1, D2, D3 and D4 are glowing. So we are receiving perfectly. The differential phase shift keying modulation and demodulation scheme is working faithfully. This completes the experiment.
At MSR, you mark your imagination.